the first thing I want to do is talk about, our main formula, of course, to get our z-score. Okay, so what's our main formula that we're dealing with to get our z-score? Okay, good. We sing our x minus the mean over the standard deviation. Okay, so that means if you have the x value, which x is your context. Okay, so x is going to be your context value. And then, of course, z is how many standard deviations it is away from the mean. So if you have your x, your mean, and your standard deviation, that's how you can get your z. There is another way to get a z-score. What is the other way? If, say, your x or your mean or your standard deviation are missing, how else might you be able to get the z-score? Good. Z is inverse norm of the what? Area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. So those are two ways that you can get a z-score. All right. Now the main thing that we want to do with that z-score is we want to be able to understand how to get our shaded areas. So if, say, we are getting this shaded area here, we got to have a z-score on the left and a z-score on the right. And so there are several names for what this shaded area does for us. So the shaded area, you might be asked, what's the probability? Maybe they'll say, what's the probability that something falls in between, 90 and 100 miles per hour? Okay? Another one besides probability might say, what proportion of data or what proportion of observations, what proportion of cars, what proportion of socks get stuck in the dryer or whatever, I don't know, proportion of observations. Okay, and then there's one other P word that this shaded area represents. Anybody know? Good, our percent. The percent of data. Okay, good. So you either, you'll have all this z-score and all these kinds of things, but ultimately, a lot of times we're wanting to find what are these probabilities or proportions or percents. And if we do that, then what calculator steps did we go through to find those areas? Norm, C, D, F from your low z to your high z. Okay, very good. Norm C, DF, low z to high z. So what does the C stand for in this norm CDF? Do you remember? Cumulative, good, because you're accumulating all of these little pieces in that section. Okay, very good. Now, let's see if we can't remember when you use the negative 99 and the positive 99 and that kind of thing. So when would one of your z-scores be going out to negative infinity? When would we do a norm CDF? What might the question be asking us for? If you have an area below. So if I have a z-score, say this is 70 miles per hour, and I say what proportion of cars go 70 miles per hour or less, then that's basically going out to negative infinity. And how many z-scores represent negative infinity? In our calculator, we're going to represent that with negative 99. How many z-scores are on a normal curve? 3 up and 3 down is the primary ones. 3 up and 3 down. So 99 z-scores away, 99 standard deviations away, that's way far away. Way far away. All right, so in this case, we would do the area below would give us negative 99 up to that particular z-score. Okay, what if I wanted to know what proportion of puppies weigh this much? What proportion of newborn Labrador puppies weigh this much or more? Okay, then I'd have the average and the standard deviation. And so how would I get that area? Norm CDF from what? My z-score out to 99. Okay, so if I'm going above, then I'm going from a z-score out to positive 99. If I'm going below, then I'm going from negative 99 up to my z-score. Okay, so there's kind of our review. And so what you're going to be doing in a minute as far as your homework goes is you're going to be, after we go over a few of the ones from last night, your homework will be pages 19 to 22 in your packet. And so here, you know, you've got some basic information. By the way, if I'm getting a z-score and I have a percent, a top 15%, tell me what I need to do to that to be able to get my z-score. Multiply by the bottom 85? Yes. Inverse norm of the area below, so not the top 15%, but the area below would be the bottom 85%. Good. And so on. Here, some people had some questions about the middle section. If I say middle 20%, then I'm going to want a z-score here and a z-score here. So I'm going to end up with 2 z-scores. Okay? And if I've got 20% in the middle, that leaves 80% split. So good. So it's 40% and 40% up here. So this z-score, what inverse norm would I do to get this left z-score? 0.4. Okay. What inverse norm would I do to get this top z-score? 0.6, because it's the 40 plus the 20. Good. What quality could you tell me about those 2 z-scores? They're going to be the same. They're symmetrical, except for one will be negative because it's on the left of the mean, and one will be positive because it's on the right. They're the same distance away from the mean, just one's on the negative side and one's on the positive. Good? Okay. Now, let me give you some techniques of how to do the word problems because we didn't really practice that much yesterday. Okay, hold on just a second. Well, go ahead. Yes, so then you will have 2 x values. You have 2 z-scores, so you will have 2 x values. Okay? All right, but now let's talk about word problems, which I don't think we really practiced that much yesterday or did many of those. And so let me kind of talk you through a technique of how to do these. It's just basically putting context to the stuff we already know how to do. You just have to start, what I recommend is start off and just go ahead and always put this little menu of items over here to the side. Okay, and then you're going to fill in the things you know and what you need to know. So here, I see, this is about cars on a motor speedway. It tells me the mean is 90 kilometers per hour. It tells me the standard deviation is 10 kilometers per hour. It says what is the probability. So I'm finding probability that a car picked at random is traveling more than 100 kilometers per hour. So what is that 100 kilometers per hour? What's that 100 value? Good. The x is your context. So 100 kilometers per hour. Now, the other thing, so we obviously don't have a z-score, but I do have mean, standard deviation, and x. So which way could I get a z-score on this problem? With your formula, x minus the mean over the standard deviation. Good. Now, the other thing I do to understand a problem, and I do this frequently, is I frequently make a quick sketch. You know, I know this is 90, I've got something up here at 100, and it wants to know the probability that a car is that kilometers per hour or more. So ultimately, this problem wants to know that shaded area. Because probability, proportion of observations, what percent of data, that's norm CDF. Okay, and because I'm going from there to infinity, I'm going to have to get my 2 z-scores, one of which will be what? Okay, well, we'll figure out that z-score, but then out to positive infinity, good, which is 99. Okay, So that's what you need to do on each one of these problems is make yourself your little menu on the side. Maybe draw a picture of what it's talking about. This one is talking about between 50 and 70, and it wants to know the probability. So that means shaded area. Okay. Now, look at here. I got the number 50 and I have the number 70. What am I going to have to do to find that area in between them? I'm going to have two z-scores because these are two x values, and so on. All right, so I'm going to have you guys practice all of this stuff again on your homework, pages 19 to 22. Now, don't forget these keywords: probability, finding the proportion of observations. When you find percentage, use norm CDF. And I do have a little song on that, which I'll play for you.